Welcome to the Digital Dimensions Simulation CADcast. Today we'll be focusing on bolt connectors. I'm your host, Brad Rock. This CADcast will cover how to define the bolt connectors, how to view the results of the bolt connectors, and finally, how the bolt connectors are solved in the SOLIDWORKS software. Let's begin by reviewing the prereqs for utilizing the bolt connectors in SOLIDWORKS simulation. Best practice for use of bolt connectors is to identify the faces which are likely to press against each other. These faces will then typically have a no penetration contact set defined between them. We will begin by reviewing the process of creating the no penetration contact set. This model is composed of two blocks. The blue block is resting on top of the teal block. To begin, we'll explode this assembly, and in the exploded state we'll have easier access to the top portion of the lower block and the bottom portion of the upper block. This will allow me to easily select the faces to define the no penetration contact set. The no penetration contact set can be accessed by right-clicking on the contact sets within the Simulation Feature Manager and selecting the option for contact set. Notice the default contact set is set at no penetration. Once the faces have been selected, selecting the green check mark will create the contact set. I can then proceed by collapsing the model and double checking that my contact set is present. Now that the no penetration contact set has been defined, we can proceed with the definition of the bolt connectors. Bolt connectors can be defined by accessing the Simulation Feature Manager, right-selecting the Connections dialog, and selecting the option for bolt. Notice that once we access the bolt connectors, we do have the ability to choose which type of bolt connector we intend to use. SOLIDWORKS Simulation offers the ability to use a counterbore standard bolt connector, a countersink bolt connector, a counterbore or standard screw connector, and a countersink screw connector. SOLIDWORKS Simulation also offers an additional feature called foundation bolt. The foundation bolt is actually utilized as a fixture. We begin defining a bolt connector by using the top selection box and selecting the top edge of a cylindrical face. Notice that once the top edge has been selected, the bolt head is automatically populated, as well as the bolt shank diameter. Following the head selection, we then rotate the model and then select the bottom edge of the bottommost cylindrical face. The first edge selected defines where the head of the bolt is placed. The first edge selected defines the location for the head of the bolt. The second edge selected defines the placement for the nut of the bolt. Now that we've defined our bolt, let's take a look at how to retrieve our results from a simulation study which has been completed, which did include a bolt connector. Let's begin by looking at some bolt connector results for this completed simulation. Notice that in the simulation, no bolt model has been added to the simulation, yet we clearly see the outline of a bolt compressing on the model. To retrieve the results of a bolt connector within SOLIDWORKS simulation, we right-click the results folder and select the option for List Pin, Bolt, and Bearing Forces. Within the Pin, Bolt, Bearing Force dialog, we see that the forces for all bolts which have been defined in the model are clearly visible. The forces are broken down into X, Y, and Z components for shear force, axial force, and the bending moment of each bolt connector. This dialog also allows us to save this information out in the form of a CSV. Now that we've seen the results for pin, bolt, and bearing forces by themselves, let's take a look at the difference in results on 3D models. This slide shows two models. The one on the left is utilizing a bolt connector to hold the model together. The one on the right is utilizing a 3D model of a bolt. Notice the results on the leftmost simulation are 760 psi max. The results on the right simulation are 748 psi max. The variation of these results is negligible. Now that we've taken a look at how to define the bolt connectors and how to retrieve the results of the bolt connectors, let's take a look at some of the more unique features of the bolt connectors. These features include the ability to define a tight fit condition, the ability to add a preload, and finally, the ability to add a bolt series. To begin a review of these more unique features within the SOLIDWORKS bolt connectors, let's take a look at preload. Preload is also referred to as pretension. Pretension is denoted by the tension condition determined when adding a loading force to the bolt. When preload is defined in a bolt connector, it's important to note that a second cycle will occur within the solver to account for the load condition. This is why, when a zero preload condition has been defined, you receive this message explaining that a preload condition does not exist. And now moving forward, let's take a look at one of the other conditions known as preload. Editing my contact, I note that the preload of the bolt has been defined at a 30 kilograms force per centimeter. This is why when we view the results, we see the compressive force from the bolt affecting the model. And now, moving forward, let's take a look at one of the other conditions. Within the SOLIDWORKS options, we also have the ability to define a tight fit condition. Each bolt is defined as either loose fit or tight fit. For the loose fit, the bolts are modeled with only end caps and a rigid contact set between each cap. For the tight fit bolt, rigid caps are applied on each end of the model. Rigid connectors are defined between the tetrahedrals of these cylindrical faces. To better understand the rigid connections in the tight fit condition, please see the attached model. The teal triangles represent the rigid connectors, where the yellow rectangles represent the shank or the threaded portion of your bolt. To interrogate the different results between the tight fit and loose fit conditions, I prepared the following two simulation studies. The loose fit study has the bolt connector as no tight fit condition defined. Notice that the upper portion of the model, we see a clear deviation from the normal linear cylindrical face. In the tight fit model, when we view the results, we see that the stress propagation is at the interface between the two parts, and looking at the deformed results, we still see a linear cross-section in the cylindrical face. Moving forward again, we come to the option for bolt series. Bolt series is a connection set which is used to accommodate bolt connectors which pass through three or more parts. The intermediate parts thereby become sandwiched and utilized in the bolt series. Defining the bolt series connection is accomplished the same way as defining a regular bolt connection. At first, the no penetration contact set must be set between all faces which are likely to press against each other. In this scenario, you'll see that contact set 2 has been generated to denote a no penetration contact between the first part and the second part. Additionally, contact set 1 has been generated to generate a no penetration contact set between part 2 and part 3. Performing an edit definition on the bolt contact shows that the uppermost selection, or the head of the bolt, is selected at the top surface of the part. The purple selection is selected from the bottommost surface of the bottommost part. Moving to the advanced options, we see that the bolt series is checked and that the three selected faces are all three cylindrical faces which are concentric. Now that we've covered all of the options for the bolt connectors, let's take a look at some of the other connector options, such as the screw. Looking at the initial results from the screw connector study, you see the results look very similar to those obtained from the bolt connector. Additionally, notice that the setup looks nearly identical. The no penetration contact sets are still defined between each of the three parts. When performing an edit definition on the screw connector, Note that the upper selection is still the head of the screw and is selected at the top uppermost model. The second selection is now asking you to select a threaded face. The threaded face is going to be a concentric cylindrical face. Also notice that many of the options available in the bolt connectors, such as the tight fit condition and the preload conditions, are available within the screw connector. Finally, notice that with this three-part assembly, we did utilize the bolt series to select the sandwiched part. The final bolt connector we're going to cover today will be the foundation bolt. In order to define a foundation bolt, a virtual wall must first be designated. The virtual wall is then utilized during the creation of the foundation bolt as the location at which the foundation bolt is secured to. To begin defining the foundation bolt, I will use the simplified version of the model we've used throughout the rest of the video. To begin defining the foundation bolt, right-click again on the Connections folder and select the option for Bolt. Once the Connectors feature manager has appeared, change the option type over to Foundation Bolt. Notice that for defining the foundation bolt, you are still required to select the uppermost edge for the placement of the bolt head. The second option does ask you for a plane selection. Notice the yellow warning denoting that a virtual wall must be defined in order to define the foundation bolt. I'm going to cancel out of the foundation bolt setup and we'll quickly create a virtual wall. The virtual wall is created by right-clicking on the Connections folder and select the option for contact set. I'll then change the type from the no penetration contact set to a virtual wall setup. Notice that I am required to select both a face and a plane. For this model, I will select the face of the part and the top plane of the assembly. Once the virtual wall has been defined, I will then add the foundation bolt by right-clicking on the connectors and again selecting the option for Bolt. Once the bolt feature manager has appeared, I will select the foundation bolt type. And from the foundation bolt type, I will then select the uppermost edges as the placement for the bolt head, and I'll select the same plane as was used to generate the virtual wall. With the addition of the foundation bolt, you'll notice that the fixtures folder now includes 3 fixtures. The first fixture, the foundation bolt, the second fixture, which is the virtual wall, and finally the third fixture, which I've denoted as a roller slider to restrain some of the degrees of freedom within the model. Once the foundation bolt has been set, I'll go ahead and run the analysis. And once the analysis has completed the run, I'll then interrogate the results by right-clicking on the results folder and selecting the option List Pin Bolt Bearing Forces. Now finally, we will review the 3 steps to solving the bolt connectors in SOLIDWORKS simulation. The first step in solving a bolt connector within SOLIDWORKS simulation is to calculate the tensile stress. The second step involves calculating the bending load ratio and the shear load ratio from the bending and shear load data calculated during the analysis. The final step in calculating bolt connector results is to calculate the axial load ratio. The axial load ratio is derived from the equation shown below. Thank you for watching this DDI CADcast. Please visit us at www.ddicad.com.